Find the vertex, focus, directrix, and axis of symmetry, then graph the parabola. So we've been given the equation 8y squared plus 4x equals 0, which is not in one of the standard forms of the equation of a parabola. And so right away, I know I want to make it into one of the standard forms. And because I just see that y squared and that x term without anything else going on there, I know it's actually in one of the forms where I have a vertex at the origin. So an x squared equals 4py. And then what we actually have here, a y squared equals 4px. And so I can go on and think about having taken the minus 4x away from both sides, and then I would divide by 8. And this is a y squared equals minus 1 over 2 times x. Right, so it's in this format, but I thought we'd take a moment just to talk about the standard forms. When I have an x squared equals 4py, then my parabola either opens upward or downward, depending on the value of p. We open upward when p is positive and downward when p is negative. Our vertex is at the origin. We'd see an x minus h or y minus k if the vertex had been shifted. My focus is p units away from the vertex, and so here it's either an up or a down, so it's at 0 comma p. If it's positive, it's above, and if p is negative, then my focus is below my vertex. My directrix is, in this case, a horizontal line, so it's a y equals the opposite of p. And then finally, the axis of symmetry would be the y-axis with a vertex at the origin. And that's the equation x equals 0. All right, the case we actually have, a y squared equals 4px. My parabola either faces to the right or it opens to the left. To the right would be when p is positive, and to the left is when p is negative. Our vertex still at the origin, but this time the focus, well, we've either gone to the right or to the left to find that focus. So that would be a p comma 0. Our directrix this time would be a vertical line at x equals the opposite of p. And then the axis of symmetry running right down the middle of a parabola along the x-axis with a vertex at the origin would be the equation y equals 0. All right, so now our job is to think about where the vertex, focus, directrix, and all of this stuff is for this particular parabola. We're definitely in this format, so we're facing to the right or left. And right away with a minus out front, I see that 4 times p is equal to minus 1/2. So p is equal to minus 1/8, and I'm definitely facing to the left. We're going to find a vertex, a focus, a directrix, and an axis of symmetry. Then we're going to sketch a graph. Well, that is if we did things in this order, which you can certainly do, but I would always like to kind of just go on and get a sketch started. My p value is a minus 1/8, which means my focus is only 1/8 of a unit away from the vertex. And so I'm just going to count by 1/8 until I get out to 1. And that should give me a scale that's appropriate for the problem. All right, so now I could go on and plot my vertex. And I like to think visually from here, right? My focus is supposed to be 1/8 of a unit away, but in a horizontal direction, which makes it right there. So there's my vertex and there's my focus. Now, I want to sketch my parabola. Let's go on and write down where that focus is at minus 1/8 comma 0. And what I can do to sketch this parabola is, instead of finding 2 other points on it by plugging in x's, which we can certainly do, or plugging in y's, whatever you feel like, see, I know that the focal diameter is equal to the absolute value of the value of 4p. And so here, 4p is minus 1/2, so that my focal diameter is positive half. So what the focal diameter is a line segment that runs through the focus parallel to the directrix that would have length 1/2. So I'd need to go up 1/2, up 1/4 and down 1/4. All right, so that's 2/8, up 2/8 and down 2/8, and my parabola has to run through those 2 points. All right, the only thing missing from my diagram now is the directrix. Here, a vertical line 1/8 of a unit the other way from the focus. And that is an x equals 1/8. And then my axis of symmetry here is the x-axis, or y is equal to 0. All right, we've accomplished everything we were asked for, but one thing I always just kind of like to think about when I've graphed a parabola is if I draw a line segment between the focus and any point on the parabola, and then a line segment that's perpendicular to the directrix, and I label them as having a distance d1 and d2, then those distances are the same, because that's what a parabola is. And that's it for now.